Welcome back. I'm doing my little tandem screen capture with my cell phone. I know it's not the best, but this is a little bit of a side note. Those of you that have seen my other idea for a 3D printer using my V channel or L channel aluminum extrusions, I was thinking the other night, and in about an hour or so, I changed the way that the end carrier blocks work. So if you can see here, I'm just going to go to, they're mirror images, so I'm just going to go into this one here. The bearing carrier, or bushing, could be bearing or bushing. I mean, I'm planning on using PLA bushings. You could put the UUM8 bearings in here. Has a little expansion slot there, but as you can see, I just have the one bearing stuck in there. There's room for a zip tie to go through the body and out here, so it would go around the barrel of that, so you could tighten it down on the top bushing and the bottom bushing. The L channel, let's see if I got this the right way. I'm just going to temporarily flip this to see-through. The L channel will come right inside. Now, the screw to mount the end plates will come in the bottom, so what you do is just notch out a bit of the bottom of your L channel, or maybe only bring it down to the top of the screw. There's now a set screw in the middle here, so you can drill out a slot, or when you get it in the correct depth, you could drill a hole through this and then put an M3 nut through. And on the inside there's a flat, if you see the bottom here is the mirror image, there's a flat, just pop that back to color, there's a flat bit of plastic that would also receive M3 screw, so you would have something to actually permanently, well, not permanently, but something to actually forcibly anchor the L channels. I've gotten rid of the open area where the L channels came in on the other one. It was plenty of strength there, but I'd lost some friction and there wasn't a whole lot of meat to it. So I still am probably going to try the horizontal alignment, but the more I look at this, where I have all this room back here for the belt and attaching of the belt to the actual carriage itself, and the X carriage is quite large. I mean, you could use this for small CNC or mounting a laser or anything. So there's another advantage mechanically when it comes to using bearings like this. The other one would be capturing the bearings in the space in between here, and that's not a lot of room. So if you have, and I'm just going to say a 0.5 millimeter of play in a space that's only, say, 4 centimeters, the rocking motion that you'll see on anything out from that will be much bigger than when you have, say, that 0.5 millimeter of play spread across 8 centimeters. In fact, it'll be slightly less than half. So you gain some rigidity, or I'm trying to find the word for it, but stability essentially, but it will feel more rigid even though there might be the same amount of play in the V-groove bearings. I didn't fully model V-groove bearings, I wasn't going to take the time for that, but you get the idea. The V-groove bearings will sit on the top and bottom, but I could very easily have my 4 ball bearing version, which has regular ball bearings that sit on either face. That is incredibly rigid. The one that uses the full 4 ball bearings has very little play or slop at all. So that will also be an experiment to see which way we go there. Now, I'll just have that up there like that. Don't know if this is going to focus here. Probably not, because it's backlit. This originally is how the nut for the Z-axis screw, the threaded rod, which is, there's one right here and one right here, originally would have gone up, and using that capture block to mount to a little bit of an isolator block or something to allow the Z-axis travel. On this one, I've incorporated that block. See if I can remember the right mouse button here. I've incorporated that block into the actual part, and on the side here there's a place to put a set screw if I find it's moving, but I don't think it'll be moving. Should be pretty tight friction fit. And there's also a place here for me to put a screw in case I want to put a washer that will hold the top of this bearing and the top of the set screw from coming up, because most of the force on that screw is actually going to be up. Gravity down is not going to be a big factor. Excuse my cough there. So we've got that, so we're not worried about gravity down. The thing about this, and I'm just going to duplicate one here. Duplicate. It's been duplicated. So we'll pull this down here and put it down on the ground, so to speak. Bear with me a sec. Okay. So this is the part. Now, looking at it, it looks pretty complex, but it's actually designed, that part is actually designed to be printed on a Fabricator Mini. So the way you would print it is like this. Let's just set that to 0. So that would be sitting on your Fabricator Mini like this. You shouldn't need any supports. If your Fabricator Mini is dialed in, this should just print like that without any supports. And you print this in its mirror image, so really you only need one file and then just mirror image it, which is of course using a negative scale in Fabricator Mini on one axis. If you're in Repetier Host, or I could put up both parts for those that aren't into that. But the other thing about this, while I have it here, is, and going forward in the future, this L-channel holding area could be redone in your 3D print, in Tinkercad or anything you can edit STL file, to hold 8mm or even 12mm round bar stock, or even flat stock for some of you guys that have been using round bar and then flat stock. I don't know what you call it, but essentially it's just a flat chunk of steel or aluminum that your rollers hang on. You can change that, because this side is the simple side, and you just have to make sure you've got enough room for your belt to come down here. And it's T2 timing belt, so the stuff's only, I think, 5 or 6 millimeters wide. I got a piece right here. Timing belt is only about 5 or 6 millimeters wide, so that's only easy. But yeah, that's the part. It was completely done inside Tinkercad. People will say that I've had a few people tell me that it's hard to get things done in Tinkercad, and it's actually not. If you watch Chuck Hellebuck, you'll see he does some very practical things in Tinkercad. I do a lot of my stuff inside Tinkercad, and I don't find it hard at all. It's additive and subtractive modeling. CSG is something we used to call in the gaming side, constructed solid geometry. Wow, can't talk today. You just have to think about things, and then you have to take a step further. I'm just going to shut that ruler off because it's annoying me. Actually, let's pull you out over the white, because there's another trick inside Tinkercad for seeing stuff. If you have the hole mode on, which is a neat way to kind of get a quick wireframe render, it tends to look a little bit better over the regular white and not the blue. See how it kind of blurs a little bit in the corner there? But inside this, you can actually see the paths for the zip ties, and all that is just making use of some of the shape generators that are available to you in Tinkercad, laying them out, figuring out that subpart, and then putting it in and figuring out whether it's an add or a subtract. Knowing your 3D printer helps, because then you know what you can get away with. For example, I know that this hole here, I think it's 18 millimeters, is not going to be a problem. This size here is not going to be a problem for my Fabricator Mini, because I've already printed one like that twice on the other parts. I'm not 100% sure about the apex here at the top. I'm not sure if this angle is too much of a steep, let's get that back in the middle, if this angle here is too much of a steep overhang, but it should be alright. I know the arch down here is going to print just fine, and that's where the little nut is going to sit when you bolt on the motor or the pulley tensioner side. But this part should be a single piece, single print end, so you can do this on either end. And hopefully it should be a direct bolt into what I'm already working. So once I test the system that I have now, because I've got those bigger parts printed out, I'm gonna plan on swapping out to this. It's gonna make more of a, I mean, if you look at the setup in the back, don't worry about the mirrored things on the top, but if you look at the setup, that's a pretty I'm gonna say classic printer layout there, with the lead screw part, and then the guide shaft here, or the 8mm rail guiding it. In this setup, the stepper motor, which is represented by this hole, or this shaded transparent block, it's actually a tiny bit bigger than it is in real life, but because there is more room for the zip ties to come out on this edge here. But the stepper motor hangs forward, and the whatever you have for a print head will hang on the front side of this, and then you have a little bit of clearance on the back. Now these red parts, they're not done. They're going to have some bolts that allow for adjustment, but this allows me to use M3 screws to attach the blue part to the red part on the printer, but the red parts will take final alignment on the wood. It's just something I was thinking of. There might be a better way, and I'm sure there is, and I'll get to that. But where my printer is meant to be a design test bed and fairly modular, a lot of these parts are going to stay modular. But I think this one, before I even have version 2 off the printer, and so to speak, and set up, I think this one is going to give a better outcome. Like if you see here, I was just quickly sketching up the X carriage part. It basically just has to hold 4 bearings, or 8 if you're using the V-style bearing coverage. But anyhow, that's I don't know to call this an update. This is a potential version 2. I will make these files available to anybody who wants them. Just put a note down below, and don't forget to ask any questions down below. Like if you like, and don't forget to subscribe. It lets me know you guys like these kind of crazy things. And as always, thanks for watching.